Hello, today we are going to understand the another topic. So that is regarding the smart grid. So in olden days, the electricity or electrical grid or electricity grid we will call. So that is the olden grid for the power production and usage of the power grid and these all things. So nowadays it is converted to smart grid. So what is smart grid and what is the use of the main goal of the smart grid, we will understand in this particular lesson. Here you have to the main goal of smart grid nowadays is that is transforming of the traditional electronic grid, so that will be in the new form. So there is so many differences that was come today's smart grid because of the more advantages in smart grid. So what is that? So advancement of the traditional electrical grid. So in the traditional electrical grid, what was there? So energy generation is done in centralized power plants. So that means generally the power plants will produce the electricity, or energy generation will be done through the centralized power plants. And next is energy distribution is in one direction only. So the data sending from only in the one direction, from the power plant to the homes or the industries. There is no two-way communication. Monitoring of resortation of grids is not done, is done manually. Sometimes some of the areas having some electricity problem, or the power is not provided. So then any problem with this particular electrical grids, so that was done through manually by through manpower. Unidirectional communication is the main disadvantage in the traditional electrical grid. So if you take the smart grid, this is the advancement. So smart grid achievements achieve the highly reliable in power systems. Reliability. So reliability in the sense we are more efficient and flexible power consumption. A cyber physical system, so that means collection of sensors and actuators and these all things. Cyber physical systems, IoT devices, sorry, ICT devices, equipped with the sustainable models of energy production and distribution and uses. So that is the main goal of smart grid. Now we will see some figures here. So generally the power production will be developed from the power plants. Generally, so nowadays the power production can be done using the solar panels and through wind power from water supplies nowadays. So that will be produced over the cities and states of the countries. And if you go for electricity, so the electricity through antennas, through major power supplies, so that is going through in a single direction. So in this picture what I am showing here is there is a set of sensors that was there, and actuators that is known as IoT devices, which is fixed equipped with this power plant, or the antennas, which is going to store some information to tell the power stations, to give certain information to the power stations. And so we are going to get the data from the renewable resources, like wind and solar contents. We already seen from wind and solar, we are getting the renewable services in the smart grid. So in the olden traditional electrical grid, so the data from power plant to directly through infrastructure, and infrastructure to homes only. So that means In unidirection only the data is and the power is going to be produced, unfortunately. So power failures will be happen in between. So power plant don't know so what is the situation and status of the power in the homes. That is the reason why the smart grids was established. So in this particular diagram, we are seeing that so power plant produces the power to the all different stations, different gateways provides the power to different cities. Unfortunately, if any set of power, any set of city or colony got powered off, in the figure we are seeing that. So in one range of city was powered off because of some problem. So in that particular situation, so if nowadays in the smart grids there are sensors and other technology which gives the data to the power stations automatically, then what happened, it will be automatically sets, it will be automatically generates the power to that particular station or that particular city, because that is the restoration situation. So it will be automatically done nowadays because they are using the smart grids. So nowadays this is the two-way communication because of we are using different types of smart devices, smart IoT devices. In the smart communication and smart grid, there is a two-way communication between different infrastructures and the homes or industries for supplying the power. Next thing is what is a smart grid? Simply, so till now what we understand, that same thing was there. Smart grid is a conceptualized as a planned national-wide network that uses the information technology to deliver electricity and efficiently, reliability and securely. Smart grid is also named as electricity with a brain and the energy internet and the electronet. And according to the definition given by NIST, smart grid is a motorized grid that enables the bidirectional flow of energy, we already discussed in the previous slides, and uses two-way communication and control capabilities that will lead to an array of new functionalities and applications. So benefits of smart grid. The benefits associated with smart grid includes more efficient transmission of electricities, quicker restoration of electricity after power disturbances. For example, we already understand it in the previous slide. Reduced operations and management costs for utilities, and ultimately low power cost for consumers. So in so many areas like hospitals, this smart grid was used because of different IoT devices that was monitored of monitoration of the power, and power management will be done within the industries because of the wireless sensors. Reduced peak demand, which will also help lower electricity rates. That means in the peak demand, so reduced peak demand also, which is also help to low electricity rates. Increased integration and large scale renewable energy resource systems. Better integration of customer owner power generation systems. So that means every time, so in the smart cities we have a 24 by 7 power generation which will be there. And so these are the major things. Efficient transmissions, no restoration whenever the power disturbances happen, and operational management costs utilities, and reduced peak demand at help of low electricity rates, increased integration at large scale renewable energy systems. For these all benefits, we are using the smart grid. So benefits of customers, what are the benefits? Updated information on their energy uses in the real time. So nowadays, using their mobiles, they are seeing what is the electricity bill, what is the how many units they consumed. These all things are seeing. Enables electric cars, smart appliances, and other smart devices to be charged. Program the smart devices to run during off-peak hours to lower energy bills. That means automatically the smart devices, there will be a program that smart devices. So using the smart devices, we will be run off the devices or peak hours to energy bills to reduce the energy bills. Different pricing options like this. And benefits of stakeholders, so who provided the power, energy grid or smart grid. Increase the grid reliability, reduce the frequency of power blackouts and brownouts, provide infrastructure for monitoring, analysis and decision making, increase grid resilience by providing detailed information, reduce inefficiencies in energy delivery, integrate the sustainable resources of wind and solar alongside the man grid, improve the management of distribution energy resources, include the microgrid operations and storage management. So these are all these important benefits of the stakeholder. So that means automatically, so it reduces the frequency of power blackouts. Provide the infrastructure for monitoring and analysis of the decision making. What everything was analyzed and monitored by the stakeholder. So resilience by providing the detailed information, so that gives the increased grid, so how much power to be supplied to whom, this will be understood. Reduce the inefficiencies in energy delivery. So that means in the case they providing lots of electricity in some places which is not required. Sometimes there is lots of electricity will required in some places, but they are giving the less. So these all things will be monitored and managed. uh, that is the thing here. And properties of the smart grid, if you go for the properties of the smart grid: consumer participation, real-time monitoring of consumption, control of smart appliances. You can also control using a smart appliances like IoT devices, building automations, real-time pricing, distributed generation. So that means integration of renewable energy resources and integration of microgrid. And in power system efficiency, power monitoring, management of optimal utilizations, and automation and production. So power quality means self-healing and frequency monitor and controlling, load forecasting and anticipation of disturbances. So it clearly understand. So in previous classes also we understand some of the things. A smart grid architecture, how the smart grid architecture, please please note that, please, it was an important thing. So whenever you are going to write regarding a smart grid, it was very important. So this diagram was important, please remember. So whenever you are going for an examinations, this was an important. Home appliances, like every home area networks. In previous lessons we already understand the concept of hands, which consisting of the smart meter and smart appliances to different uh, smart appliances for controlling of various IoT devices for power consumptions. And we have a set of nodes, that means electric meters in the near houses and near energy power stations. So that is also called as nodes and gateways. So that is known as the particular area in the figure we called that was a neighbor area network, NAN. Neighbor area network will collects the data, data. That means in the two-way communication, it will be comes from nodes to home appliances, or home appliances to node, node to gateway, and gateway to directly power stations. In between we have a metadata buffer, so data aggregator unit will be there, so which tells that how much power consumption is going on in a particular home or particular node, how much power consumption is going on, and through a particular gateway how much power consumption is going on. These all things will be calculated using a data aggregator unit, DAU, through metadata buffer. And from DAU through wide area networks, that means we can transfer the power or electricity to longer distances or longer areas through antennas. That is also known as metadata management. That was done in the power management system. How we are going to calculate through IP addresses, because of in that particular IP network, all the different types of power transmission and distribution antennas will be there. So every particular antenna consisting of IP addresses, or a sensor and actuators seeing things of these there. Through that we can identify how much of power is going to be consuming. These all things will be noted down by the power generation or power plants. So that is the basic architecture of the smart grid. That is the basic architecture of the smart grid and smart grid domains. So in the conceptual model, so the transmission of electricity is done through operations, through the service provider to operations, to marketing to service provider. Everything will be in the mediator and distributed sensors. It will be in the network architecture. So there will be a lots and lots of problems in the conceptual model. That's why the new architecture was came. That was smart grid, we already understand it. So the what is the components of the smart grid? So in the smart home we have different types of smart appliances, that was called as IoT devices. And in the smart grid also uses the renewable energy resources like wind stations and solar power stations, and consumer engagement. So that means whenever a particular city or a particular station not having a electricity, so automatic restoration will be there. And operation center will maintains how much of power supply to be generated, and how much power which is consumed by each and every node or each and every home will be identified by the power stations or operation centers. And distribution intelligence, that means whenever a certain area loses the power supply, automatically identified through sensors and then supply the power. And plug-in electric vehicles, so for example other particular equipment, how much the components like cars and other important components in the home, how much electricity they are consuming, and total power is going to be calculated, processed, and identified by the power stations. In the smart home, we already understand it. Smart home uses the emerging smart grid technologies to save energy, seek out the lowest rates, and contribute to the smooth and efficient functioning of our electric grid. So the interactive relationship between the grid operators and utilities and consumers helps in proper functioning of smart grid technologies, because they are using different types of IoT elements. So the relationship between the grid operators and the consumers is very helpful. Is very helpful. And computerized control is smart homes helps to minimize the energy. So because they will in the home appliances, smart appliances and the home area networks will identify how much of power will be easily identified by the persons in that particular home. uh, like this, these all things is going to be understood. Smart home depends on smart meters, smart home energy management systems, smart appliances, home power generation. These all things in the smart home. Smart meters, what smart meters will go, smart meters provides the smart grid interface between the consumer and energy service provider. It will be operates digitally, and information between the consumer and the energy service provider. It reduces to energy cost of the consumers, and information about the usage of electricity in different service areas. These all things. And home energy management like allows the consumer to track the energy usage, monitor the real-time information prices, create the settings automatically for the power, balance the energy load. These all things. And other important thing is smart appliances like automated and robust in nature, and signals from energy service provided to avoid using the energy during the times of peak demand. Home power generations, that means rooftop solar electric systems, small wind turbines, small hydropower systems like this. So this will be used to generate auto power for their smart homes. Thank you.